All right, so you ready for some examples? Let's hit it. Let's start here, okay? In this diagram, we're given that segment AC and segment BC are tangent to circle P, and we are looking for the length of segment AC. So look at what we're given right here. All right, we know that AC is tangent to circle P. We know that BC is tangent to circle P, and we want to know what the length of AC is here. So we're going to use one of those relationships that tells us that two tangents drawn to the same circle will generate congruent segments. So since we know that these segments are congruent, we can set those expressions equal to each other, solve for x, and then back substitute to find the length of the segment. We can definitely say 5x plus 1 is equal to 2x plus 7. Now if we subtract 2x from both sides and subtract a 1 from both sides, we would end up with 3x is equal to 6, and therefore x is equal to 2. Now we're going to sub that back in, and we're going to say that the length of AC is 2 times 2 plus 7, otherwise known as 11 units in length. Okay, next example is this one right here. We have a circle, and we've got this triangle drawn, and we want to know, is DF, segment DF, tangent to circle G? And the way we would know this is if we have a right angle formed at that point of tangency. So we can use Pythagorean theorem to see, is this a right angle? All right, so let's give that a shot. Oh, do I have all three side lengths? Huh. I know this length is 12. I know this length is 20. But this length? You gotta use your thinking cap and know that this part is 8, so this would also have to be 8. They're both radii. So that length is gonna be 16. So we're gonna try out this relationship. Is 12 squared plus 16 squared equal to 20 squared? I don't know, let's find out. 12 squared is 144. 16 squared is 256. Is that equal to 20 squared? 20 times 20, I think that's 400. And indeed, that's true. Okay, so what that means is the Pythagorean theorem holds, which means this must be a right angle, and that means that this is tangent, and that would be your justification. Okay, how about this one down here? We have a circle, and we're told that segment XY is tangent to circle Z, and we want to find the length of XY. Now, at first glance, it doesn't look like I have enough information. Now, I do know that if it's tangent, I can say that this is a right angle. All right? But what do we know about WZ? What would you classify WZ as? Hopefully you would say a radius, which is the same as XZ. So we can actually say that this is also a radius. And now I can go ahead and use my Pythagorean theorem to find out what this is. Now remember, with Pythagorean theorem, a squared plus b squared is equal to c squared, as long as c represents the hypotenuse. So we need to make sure we put the right things in the right places. Okay, so if I have a squared plus b squared is equal to c squared, with that c representing the hypotenuse, c would be 10, because 4 plus 6 is 10. One of those legs is going to be 6, and it doesn't matter which one. All right, and then I need to solve for the other one. So this is 36, and this is 100, right? So b squared would be 100 minus 36, which is 64. And so in this case, our last side length is going to be 8 units, okay? All right, let's look at this one. This one is kind of a fun puzzle, all right, because I have this circle, and it's inscribed in this polygon. It's a quadrilateral, all right? And all I know is some parts of the side lengths. I also know that the lines are tangent. Okay, all those lines are tangent to the circle. And I am interested in the perimeter. Okay. 13.4 plus 21.9 plus 20.5 plus, I don't know anything on that fourth side. Okay, so this is where we're going to do a little bit of puzzling out what we need to find. We're going to use that first tangent property that says any two tangent lines are going to create congruent segments. All right, and so that means that this tangent and this tangent are going to be the same. So this right here is going to be 5.4. All right, that helps with part of this. But for this part, I still don't know. But what I do know is I can figure out what this length is because I know that this whole thing is 13.4. So this part would have to be 8. 8 plus 5.4 is 13.4. Okay, well, if this is 8, then this would have to be 8. And this 8, then I could find by taking from 21.9 this piece right here. So I think that that's going to be 13.9 because 8 and 13.9 do give me 21.9, which means that this part right here is 13.9. And if I take that from 20.5, what's that going to give us? 6.6. Okay, and so that's my missing piece right there. So then all I have to do is add up what I've gotten for my side legs. 12, 13.4, 21.9, and 20.5. And I think that all sums up to 67.8. All right, ready? Last one. Ready for this? All right. ST is tangent to circle R. I need to find the length of X. Tangent means what? I only have one tangent, so that means I'm dealing with that right angle relationship, right? So here's your right angle. So I'm probably going to use Pythagorean theorem, but I only have stuff on two sides. Unless I recognize something. What do you recognize? Can you see it? Can you see it? Tell me about this piece right here. What is it? It's a radius. And that is 2. So they're going to be the same. So both of these are going to be X. Now I can use this to form a Pythagorean theorem relationship. A squared plus B squared equals C squared. So X squared plus 16 squared is going to be X plus 8 squared. Okay, got it? All right, now remember when you square that binomial, you're multiplying X plus 8 times X plus 8. So I end up with X squared plus 256 is equal to X squared plus 16X plus 64. Now I can subtract the X squareds from both sides. That's nice. And then I don't have to deal with the X squared piece. What I have then is 256 is equal to 16X plus 64. Shift that 64 to the other side. 192 is equal to 16X, and that's going to tell us that X is equal to 12. All right, see you next time.